All right, let's do example 2.2.2. I have a matrix M, which is 1, 2, 0, 0, and I want to consider the linear transformation that sends a 2 by 2 matrix A to M times A. I'm asked to find a basis for the kernel of T, and I need to find the nullity of T. All right, so I want to remind you that the kernel of T is every matrix here, so that T of A is 0, so we're 2 by 2 matrices. This is the 0 matrix. All right, so what I'm going to do is I'm going to take A to be a matrix A, B, C, D, and then I'm going to look at T of A. T of A is M times A, and so I will get A plus 2C, B plus 2D, 0 plus 0, and 0 plus 0. So I need this to be 0, 0, 0, 0. That's the condition to be in my subspace. So that means I have A plus 2C is 0, and B plus 2D is 0. So I'm going to take A to be, actually let's put it in a system just to make sure everything is kosher. All right, so I get something like this. I have two free variables, so I'm going to get two generators. And so I get A is minus 2s, B is minus 2t, C is s, and D is t. All right, so if I have to write my matrix, I'll get minus 2s, minus 2t, s, and t. I can split it according to parameters. Oh, I'm a bit tight here. Let me lower this. All right, so I get s times minus 2, 0, 1, 0, and t multiplies 0, minus 2, 0, 1, and that's true for any s and t. And so this tells me that I have two generators. Notice that they're linearly independent. There are two different ways of seeing that, either because they come from a linear system, remember those are always linearly independent, or because if you look at these entries, I have 1, 1, and 1, 0, and so that's gonna settle it. And so my basis is gonna be minus 2, 0, 1, 0, and 0, minus 2, 0, 1, and the nullity, which is the dimension, is going to be 2. So this is a basis for kernel. All right. Now we need to find a basis for the image and find the rank of T. All right, so if you remember, the image of T was the set of all image for every, well, in this case, every matrix. So we already have what T of A is. We said T of A was A plus 2C, 0, B plus 2D, 0. Right, so just because of the shape, we notice that we have 2 zeros here. So it's clear that this is inside the set of all matrices that have, let me use different variables, but E and F, and then 0, 0. All right, so my image is within this. I claim that I hid everything in it. So at this point, what I have is that the image of T is inside this set. So I need to show that I can hit everything in it, but if I look at EF00, I just need to write it as t of something. Well, if I take A to be E, and C to be 0, B to be F, and D to be 0, then that's going to hit it for sure. And so we have our description for the image. Everything in the image has 2 zeros here, so it looks like this. And everything that looks like this is the image of itself. And so what we get is that the image of t is this set right there. But I could also write this as E times 1, 0, 0, 0 plus F times 0, 1, 0, 0. And so again, we have our span. All right, so this is the span of 1, 0, 0, 0 and 0, 1, 0, 0. Notice again that these are clearly linearly independent because they have entries that are 1 next to. So this one has a 0 next to it, and this one has a 0 next to it. But you could also say that these are linearly independent because they're part of the standard basis. Right, and so the basis for the image of t is 1, 0, 0, 0, 0, 1, 0, 0, and so the nullity, not the nullity, the rank of t, that's the dimension of the image, and so it's going to be 2.